Assalamualaikum and good day everyone. So this is Alkyne, another functional groups in organic chemistry. Again, this is only supplementary video to your notes. You may complete this with the provided additional exercises, and I hope you will have further understanding about alkyne. So alkyne, that like most of you have known, that it is carbon-carbon triple bond. And so the first component that we're going to learn is about the naming of alkyne. So basically it will follow the general IUPAC naming that I have mentioned earlier. Basically you will find the longest chain containing the triple bonds, and then you will substitute the A and E to Y and E, and then you will show where is your Y and E. Where is your the first carbon that you see in your triple bonds. So you may, this is an example, so but1 ine, so it is butine, but you have to show where is your carbon-carbon double bonds. So if you have ethyne, for example, you don't need to write it down. If you have propyne, also you don't need to write it down because it always be at carbon 1. Now, there are several ways to synthesize alkyne. You may want to synthesize alkyne by removing the HX from dihalides. Okay, you can use this like when you want to make alkene, you can use alkyl halide to make alkene using a strong base such as potassium hydroxide or sodium hydroxide. In this case also, you may want to use potassium hydroxide again. Okay, for example, you have dihalide 2,3-dibromo-pentane over there. It will be converted to pentine. Okay, pentyne. Okay, if you have previously, if you look at alkyl halide examples, if we have only one halogen atom in, okay, we will produce double bond. If we have two halogen atom, you will produce triple bonds. Okay, this is another simpler way. This is actually reaction of alkyne, not a synthesis of alkyne. Okay, this is a reaction of alkyne. It will also undergo hydrogenation like the previous alkene that we have seen earlier, but to make to transfer or to change it from alkyne to alkene, you will use 2 moles of hydrogen in addition to catalysts such as platinum, palladium, or nickel. Okay. Also, there are 2 other ways to hydrogenate the alkyne. Okay, in addition to the catalyst that we have seen earlier, there is what we call as Lindlar catalyst. You may want to transfer of this straightforward to write Lindlar catalyst. The special things about this is that it will produce cis alkene. It will produce cis alkene. This will be a comparison to these ones. Okay, if you use sodium and ammonia, it will produce trans alkene. These 2 are the most important thing that you should note for alkyne. There are 2 types of catalysts that will produce different type of alkene. One is producing cis, which is Lindlar. Another is producing trans, which is sodium and ammonia. Okay. If you don't use other things such as the typical or the normal catalyst, then we will get the normal alkene. Okay, so this is the other ways to use it. This is when we want to add 2 halogens. We want to add 2 halogens. In the case of alkene, when you add 2 halogens, you will get alkyl halides. Okay, in this case, you will get vinyl dihalide, meaning you still have the double bonds, but you have another addition of the 2 halogen atom. Go back to the alkene topics to understand this further. Alright, now this is a comparison to the one that we have discussed earlier. If you have 2 moles of chlorine, if you have 2 moles of chlorine gas, then you will have tetra halogen atom. Okay, tetra halides. Now, what then when we have addition of HX? This is very similar to the one with alkene. With alkene, you will straightforward get a halide, but in this case, you will get vinyl halide, meaning you still have the double bond there, but you have addition of halogen atom. Now, this is HX addition examples. So again, this will also following Markovnikov products. Okay, Markovnikov rule, where you will add hydrogen to the carbon with more hydrogen. So in this case, you see this carbon have more hydrogen, this carbon don't have any hydrogens. Okay, you will follow that. Now, the mechanism of hydrogen halide addition is very similar to the previous hydrogen halide addition for alkene, where the later part of the reaction is when nucleophile will be attacking the cation. Okay, triple bonds abstract a proton from hydrogen halide forming vinyl cation. Then the proton adds to the least substituted carbon forming a vinyl cation. What then when we have anti-Markovnikovs? Okay, using peroxide. See, this is the very keyword that you need to find. Using peroxide, HBr can be added following anti-Markovnikov. Okay, following anti-Markovnikov. Very similar to the alkene topic that we have seen earlier. Now, hydration of alkynes. Again, we can achieve this using addition of mercuric sulfate in aqueous sulfuric acid at SKO to 1 pi bond with a Markovnikov orientation, and hydroboric shear oxidation will produce anti-Markovnikov orientation. So oxidation of alkyne, okay, similar to alkene, we may cleave the triple bonds, okay, but in the case of triple bond, of course, it will turn only into double bonds. With the double bonds, it will turn into ketone and aldehyde. So we will see here. So warm and basic cheminophore, okay, cleaves the triple bond. Ozonolysis, cleave triple bonds. Dilute neutral will oxidize them to diketone. Okay, so you can see this one. Dilute and neutral will cleave or will oxidize it to diketone. So instead of getting, so if you go back to alkene, if you use cheminophore, okay, cold and dilute, you will get a diol. But with triple bonds, okay, you will get your ketone, so diketone. So what you will observe is something like that. Okay, so because this one is CH, so you will observe something like that. Alright, this is in the case of diketone where you have terminal alkyne. Okay, so the examples here basically when you have alkyne in the middle one, so of course you will have diketone. Alright, so but ozonolysis is when you have produce carboxylic acid, alkene, give aldehyde and ketone. But with alkyne, it will produce carboxylic acid. You will use either permanganate cleavage or ozonolysis. Okay, either one you will get acid. Okay, and that's about it. Thank you so much, everyone.